But in case you are new to LLMs or you want to validate some of the best practices, we'll just quickly go over them. And then we'll focus on the needs for enterprises with regards to LLMs. What is it that they need to look at in terms of safety, cost, trust, workflow, technical choices, and then how can they take the large language models that are out there in the market and customize them for their specific needs. There are many ways to do that, so we'll discuss how and when to use which technique and what are the implications for that. These are exciting times for generative AI and large language models, and there are lots of tools and lots of emerging trends. So we'll be talking about some of those tools. How does it really affect you? And what are some of the recent developments going to mean for us? Okay. And then I'll leave you with a little bit of information on Retrieval Augmented Generation search and some of the resources that you can look at for additional information. Thank you for everybody who kind of introduced themselves. Here's my information. I know that sometimes in the session you can't really ask all the questions or you may have follow-ups. So feel free to connect with me on LinkedIn. And I also organize a meetup called Dallas AI. So if you are local to that area, then of course you're welcome, but we also have a lot of online events. So in this meetup, we work with a lot of different organizations, including schools and researchers, companies, and our goal is to help promote the knowledge of AI. So I'm going to jump into the generative AI and foundation models. So my assumption is that all of you have pretty good with the introductory stuff, but in case you missed it, foundation models are what powers large language models that you see around you today. And these models are not limited to human readable language. They can work on text, numbers, code, images, videos. All of these types of data are actually very good candidates for foundation models. And then these foundation models can be adapted for a lot of different downstream tasks. So we went from supervised learning where everybody had to create their own training data set, train a model for a given task, and then improve that model over time. And then you have another problem. You start from scratch. Yeah, there was some transfer learning, but it didn't really work that well. Transfer learning really shines with these foundation models because bulk of the training happens without a lot of labeled data and without a lot of that manual labor work that involved supervised learning before these models. So if you look at these foundation models as a big circle, then within that are the large language models, and especially the chat models. They are like subsets within those. And the characteristics of these foundation models are they're pre-trained, they're highly generalized. That means that once you train them, then you can use them for many purposes. They're very adaptable. They're not fixed. That was a problem with the earlier machine learning AI models, but they were not as adaptable. Now, because of the nature of these models, they tend to be large in terms of their network, in terms of their parameters and the nodes. But the key thing is that they're self-supervised. Now, these foundation models, they can be used for generative AI as it's popular and hot now, but they can also be used for non-generative AI. And these foundation models apply to many domains. I alluded to that earlier, that if you look at this, like natural language models is where there is a lot of interest these days, because language is so essential for solving a lot of the knowledge related problems. But these foundation models also apply to time series data, tabular data, IoT, chemistry, programming language like for code generation. So let's take a step back and see, what are the things that these models really impact. According to most research, these things will have a huge impact because most of the knowledge is currently stuck and we are not able to really use it. So we can add automation to 25% or more of our work, which means that there could be huge productivity gains from this. Wanted to share some charts. These are from a study done by McKinsey on different kinds of adoption rates and the reported use of technology in terms of current use, later use. And once you get these slides, you can click on these, go to the full study and kind of see for yourself. But this gives you a pretty good idea of which industries are getting more benefit from generative AI tools and how they're adapting over time. So it's interesting to look at what developers feel about this, because for a long time, the developers didn't think that AI was going to impact them. And now, they're able to do more and more with generative AI. So I won't be going over this in detail, but maybe this is a session in its own where we talk about the impact of generative AI on coding and developers and the tools and all of the developer experience. But the key point on the right side is that generative AI job postings are increasing the fastest among all technical jobs. And here's an example from CB Insights, where they take a couple of industries, retail and healthcare and financial services, and say, how can generative AI drive growth or improve customer experience and reduce the cost of this? So all of these can make a huge difference in terms of how we use generative AI in LLMs. So now let's talk a little bit about, if you're new to LLMs, how can you get started? Okay. We're going to talk about the type of models. There are a lot of models out there. How do you train these models? Because without really understanding that, you can't use these models for your enterprise use cases. Because for enterprise use cases, most of the time, you need to tweak the model to get the right results. We talk a little bit about prompt engineering, not a whole lot, because again, that's a very detailed topic. And we're going to talk about a little bit about safety for these models. So the foundation models that you saw before, and the large language models that are a subset of them, they are trained in a particular way. Let me see, some people are saying, okay, tell me if this helps with the quality of the view. Okay. Thank you. All right. So I'll go with this. So for these models, there's a lot of resources that are needed, because most of the heavy lifting is done on the training part. And that means you need a lot of data. You need the right kind of data for your purpose. And if you're creating a general purpose model, like GPT models, then obviously they have to be trained on a whole variety of data so that they can answer these questions. But it's not enough to just have the data. You need to prep the data and clean the data. And there are various technical aspects which will impact the results and the quality of the model. Everything from tokenization to what filters you use to make the model safe. How do you deal with conflicting situations? All of these things are important. And then, of course, you need massive infrastructure with GPUs and servers and a lot of specialized computers to train these models. And of course, it's going to be distributed training. The third part is really important, model adaptation. This is where you tune the model. And even models like ChatGPT, a lot of work was done to tune them to follow instructions and to make sure they give the kind of answers that are desired. And then the last part is going to be the inference. Like, how do you actually get the answers from these models? And then in that case, you have factors like latency, throughput, power. All of these have become very important. So once you understand these steps, then you will know that when you are ready to actually use these models in a customized fashion, where is it that you need to work and where is it that you need to spend some time to change these models. And no surprise that data part is going to be very important and the adaptation is going to be really important. So we're going to be talking about these two a lot. So we're going to come back to the instruction following in a little bit. But the key difference that ChatGPT had with its rivals had one very important technical aspect, which was reinforcement learning with human feedback. So you see, even with generative AI and foundation models, we are not able to get rid of humans because humans still have an important role, but their role has shifted from the beginning of the model towards the end of the model, where the model has been pre-trained and maybe you already made it such where it can be instruction tuned, but some of the results from the model are not desired. So the model uses reinforcement learning, but the rewards of the model come from a set of data that humans manually tag. And there are policies that are created to reward the responses which match more closely with the humans' labeled data. So PPO is a way to implement a policy for reinforcement learning. This is a key step, and there are people who are trying to improve this, or there are companies which are taking different approach for this last step, trying to even eliminate humans by implementing what's called policies or constitutions which define what the model should do. Okay. So how do you now work with these models? Like, the most basic thing is to use prompts. I think most everybody who has worked with large language models understands this. They know how important it is to use the right kind of prompts to get the right kind of answers. And there's a lot of information that's available on creating prompts and which prompts work best. My advice is, don't use cheat sheets, but try to understand why prompts are important, what should be the part of the prompt, what strategy should you have, and what are some of the best practices that are shared. So the link to my blog post about prompt crafting is here. Feel free to use that. Now, one very important thing about all of these models is that as you get ready to adapt them for enterprise use, now your requirements and the expectations from the users are going to be much higher. When you have a consumer-facing application, it can make errors and it can make mistakes. It's not like the end of the world. But once you start putting these things in front of enterprise customers, now you have to think about a lot of things, and you have to think about any of the unintentional damages to your company or to some of the trust that you have built with them. So you have to build these kind of mitigation in layers. And this is a very, very big topic currently with AI. No one in the market today can really get safety of these models right, because these models tend to hallucinate, and they come up with answers which are completely fabricated and untrue. So currently, this is an inherent limitation of the models. So what different people have done is that you have tried to create these layers where they first use the best data and improve the model so that it does not create these ungrounded statements. Then they add some safety systems on top of the model. Another layer is looking at the prompts and using guardrails and filters so that a user is not able to send a prompt which is likely to create an unsafe response. Similarly, on the output side, you can check the prompts, you can check the output of the prompts and filter them before showing it to the end user. So that's called separation. And of course, user experience in terms of the model. The model doesn't work if the safety systems are not working, and the prompts were fine, but the answer is still wrong. You can try with some messaging and user experience. Okay. But the trend is that you will be going towards AI nutrition facts. It's something like AI fact sheet. So every model will come up with a sheet that will say, okay, this was the intended use. Here's the clean data that we used. Here's how we removed the bias. And here's how our model was evaluated. We're not there yet, but companies are building this. So now let's go to the key topic, large language models for enterprise data. So here in this section, I want to share a few concepts and talk about a few things. I want to talk about how do you use these LLMs? How can they be customized? What kind of workflow is needed? And what are some of the factors that you need to keep in mind? So the first thing about these models is that there are two major types of these. First one is the closed source models, and the second is the open source models. Now, these open source models are the ones that are getting a lot of these attention. So this slide I took again from a CB Insights paper, but it does not include Llama. So it must have been a little bit dated. Although the date shows 10/27, but I think this is where you have probably heard of a lot of these vendors. The other question is, should we use one model or many models? Because in these models, you can go with the approach that I'm going to go with one large language model and use it for all kinds of purposes. There are pros and cons for these. But then there's a school of thought which believes that if you create multiple models for verticals, let's say financial services, healthcare, these industries have very specific languages, very specific terms. So if you create a model, let's say even if you create a model from scratch, which is very expensive, but because now this model has been trained on the industry-specific terminology and data, it has a much better chance of answering those specialized questions. So this is a big debate, and I took this slide from one of the presentations at a recent conference. So if you compare these closed models versus the open models, and then there are these open source models, there are a lot of different pros and cons that come with it. So the question becomes how important it is for you to own the model. How important it is to have access to the weights of the models so that you can play around with them later without having to pay every time. So the commercial closed source models are very good if you want to experiment. And the cost of using these models has been coming down. In the recent OpenAI's Dev Day, I think they reduced the prices further. So a lot of companies made a start there, and that gives them an opportunity to just do some experimentation, learn how these models work, see how good these model results could be. But there's one important factor: privacy and sensitivity. Sometimes your data is so sensitive and important that you may not want to send this over the cloud. Or maybe you don't trust the company on the other side, and in the beginning, there was a lot of concern that companies are using your data to train their model. So I think that's true today for consumers. So if you use ChatGPT, or if you have, through UI or API, they could use your data to improve the model. So that becomes a way for them to put something out there, see how well it works, under what situations it's not giving the right results, and then improve the model over time. But for enterprise use, most companies are not comfortable. Now, if you look on the right-hand side, you have these now open source models. So we talked about the closed source models, and the closed source models are not always the same, because certain companies and certain models will give you more access, more information, and more visibility into how that data was used, how the model was created, and what kind of guarantees and safeguards are there with the model. So that's why I made these two boxes, kind of show that there is some difference. Now with the open source models, you actually get the whole model. Now the challenge, to kind of cut to the chase, is that open source models are not the best in terms of performance. So they will not usually meet the details, like the metrics, evaluation metrics that open source, closed source models have. But they are very good in terms of getting you something that you can install on premise and apply it to your data, even though the results may not be that great, but you can customize them, and depending on the license, you could use them in production as well. But it does require people with skills. It does require you to kind of do all the infrastructure environment prep work. And so it's a good way to kind of get started. So now let's get to the customization section. But before I start, let me see if there are any questions in the chat or in the Q&A window. So, see a couple of questions. So yeah, we will discuss the LLM architecture and some of the tools much later. And we'll go over some of the other things as well, which are related to deployments of LLMs. So if there are no other questions, I will jump right into customizing LLMs. So let's talk a little bit about fine-tuning. So why do we even need fine-tuning? So we talked a little bit about instruction tuning. So when the large language models are created, they are not very good at following instructions from the box. So the pre-training literally allows them to predict next words in large sequences of text. So that's why sometimes if you ask them questions, they only will act as if they are just auto-completing. This is the nature of these auto-regressive models. And they are very good at creating these sequences, but they're always not always ready to follow the instruction. So one of the steps that's done is to do instruction following. But fine-tuning is slightly different because it takes a general purpose model and creates a version of this which allows you to do certain domain-specific things in a really optimized fashion. So I think a very good example is that if you take a GPT model, it's not ready to help you with coding right from the beginning. But if you fine-tune this model, and we'll talk a little bit about what is fine-tuning, then you get something like GitHub Copilot. And the analogy that this chart from deeplearning.ai uses is that if you go to a regular doctor, they're good at doing basic checkups and getting you some information about this. But if you have an issue with skin, then most likely the dermatologist, which is in this case a specialized fine-tuned profession, will be able to give you those outputs. Now the fine-tuning also reduces hallucinations or the fabricated, wrong, ungrounded answers. Now the process of fine-tuning is similar to the earlier training, but now you are using the data that is specific to your domain. So let's say you are in financial services. So now you can take some of the SEC documents, some of the other industry-specific things, and train the model. And you can give it the labeled data so that it can understand. And now it's building more and more of the knowledge related to that specific industry based on the data. So the quality of your data needs to be good. So you may say, okay, we used to do the same thing with supervised learning. So what's the difference? So I think the difference is that the model has been pre-trained on a lot of things already. So you are just trying to do the last mile. So the effort is still less and the quality of the results is much better than we used to have. So that was fine-tuning. But there's also, on the left side, something that compares basic prompting to fine-tuning. So in there certain situations, prompting will get you some specific, some good, decent results. But it has its limitations. And now, in terms of prompting, we're talking about prompt engineering where you hard code the prompts. You essentially write down the prompts one by one and you go back and forth, you experiment with the prompts and see what works. Now it's nice because you don't need anything special, you don't need any technical knowledge. As long as you know how to ask the right questions, you can get decent answers back. And for many of the consumer-facing applications, it works fine. The challenge is for the enterprise case, for more specific cases, it does not work well. And the prompts themselves have limited length that you can pass through these models. Now, but this is called the context length, and this has been increasing over time. I think in the last announcement that I saw, I guess OpenAI said they're going to do it 128K tokens for the context. But the problem that initially people had was that if you have a long prompt, the model would only look at the first part of the prompt, and then it would kind of have less attention towards the end of the long prompt. So there were a whole lot of issues with prompting, which fine-tuning can solve. Now, obviously, fine-tuning has so many benefits. You must be wondering, why don't we use fine-tuning all the time? Well, you need high-quality data, and it is not cheap. You also need the skills and the patience to spend that time to do that kind of fine-tuning. So researchers have come up with something which is in between these two. Essentially, you can do prompt tuning, which takes the best of prompting, but allows to improve the model. You see, for all these language models, once they are trained, the model weights are frozen, which means that it does not change over time, and which has its benefits, because if it's not changing, that means you're not spending any time training it. If you're continuously training it, there's a huge cost because of the size of the parameters of these models is in billions. So if you keep the model frozen, which means you don't change the weights, the inference cost is going to be less and the compute cost is going to be less. But with fine-tuning, you are changing some of the layers of the model. So there is a cost associated with it. So what is this prompt tuning that sits in between? So it is much lower cost way of adapting an AI foundation model without having to retrain the whole model and updating its weights. So I've included a link to the video. It kind of explains it. So if you're interested in that, just give it a watch and see how it works. But it uses the concepts of soft prompts, the AI-generated prompts, along with some input data, which is not in tens of thousands, it's like hundreds or 1,000, 2,000 examples, usually in a CSV file, where you have the input, the output. So it is not too difficult. It requires, so it's one of those low-code things, and with the right kind of UI, it can make things very easy. So that's something to keep in mind when you are adapting any model for an enterprise use. So here's a chart that I made that kind of compares the cost and effort and how good models performance is. So on the left side, you see prompt engineering, which is the easiest. So it has the lowest cost, but also has the lowest effectiveness. And it does not give you the kind of high-level, high-quality results. Prompt tuning, we just talked about, with few-shot soft prompts, with specific examples and instructions. That kind of gives you a little bit of more cost, but a lot more bang for your buck. Model fine-tuning, which we also talked about, where you change some of the model parameters, and now you have a new copy of them. So that's why I put them in the red over here, because now you're not in the frozen stage. You do have a new copy of the model. And depending on how much you fine-tune, the cost can be less or more. And then, of course, if you have lots and lots of money and time, You can build your own or fully customize the model as much as you want. And that's going to be really, really expensive. But there are situations in which it's justified. Let me take a look at the questions and see if I can address some of these here. Okay. So there's a question about Azure and privacy. So I cannot answer questions about a specific product because Azure and its storage and all that, you just have to check with them and see. But there are a lot of people who have concerns about this. So now the second question is, Harry, fine-tuning is extending FMs into specialized area. Yeah, I mean, it definitely is. And it's up to you how you do that. Now, regarding the RAG part, we're just going to talk about that in a little bit. So I'm not going to go in there, but we'll discuss it in a little bit. I think Brian has the same question. So just give me a minute so that we can get to that RAG part and talk about that. All right. I think hallucination, that's the easy one. When we reduce hallucination, it means that the model is giving truthful answers, or if it doesn't know, then it's going to tell you that it does not know the answer instead of coming up with one which is false, untrue, and wrong. So let's talk about tools and trends. And there's just so much happening in the world of LLMs that it's really, really hard to stay on top of them. I think I just made a list of all these. May not be able to go through all of these topics in detail, but there are many vendors, startups, as well as established companies that are offering point products. Like one company will say, oh, we'll solve privacy issue. Another company will say, we'll give you this kind of a vector database that will solve embedding problems so your search results are better. There are companies that are coming up with frameworks. Then there are these larger companies like OpenAI that are offering their own frameworks as well. There's a lot of activity in open source. There are low-code offerings which non-developers can use as well. And then there's a need for overall governance. So we'll tackle some of these topics as much as. But I think the main question is, are you a consumer of these services or are you a creator? By this, I mean, if all you want to do is to use someone else's model, you don't care about that many of the details, yeah, so then you have choices. You can use a lot of these models and services through APIs. But if you want to create something different and new, yes, then you need to do a little bit of more work because these existing services may not give you that flexibility. So you have three choices. Use APIs or use even a UI that works for you. They're like things like this Playground, which lets you create these assistants that are just brand new. Before that, there were agents and all that people had created. Now OpenAI is giving you it. Or you can use these popular frameworks like LangChain. Or you can just do something on your own. I don't know why would you do that, but that's always a possibility. To give you an example of something that is very, very new are these assistants that were announced, I think, on November 6th by OpenAI, which are essentially ways to customize a model and create an assistant with your own applications. And they have they're using three types of tools: code interpreter, retrieval, and function calling. So before that, if you wanted to call a function, you had to do some things separately. And we're going to talk about the retrieval and other things. But the key point here is, in case you missed it, now you can see what's going on. And second is give you an idea of how quickly these things move. And there's no one right way of doing things. I think there are a bunch of questions about RAG versus fine tuning, which is more effective? Where do we use vector DB? It all depends on your use case. And there are going to be use cases in which you could use one or both. So let's quickly go over why did LangChain start? What were some of the things that it does? So LangChain is a framework that allows you to work with different kinds of language models, chain your tasks, tap into vector stores, and allow you to create templates for the prompts, and then create agents that could do certain things for you. So before LangChain, there was really no good way of doing this. And everybody who did one of those things that LangChain now does, they were writing custom code. So LangChain, the founders came up with a library and SDKs that allow you to do that without having to reinvent the wheel. But now some of the things that LangChain used to do are being offered by OpenAI as well. So these are some of the components that you can see, and there's a course on deeplearning.ai that lets you see all of this, and you can kind of go through these and see. And agents were really important because LLMs by themselves, they had a knowledge cutoff based on a timeline. So the original model was 2021, and after that, it could not really look up the internet. So people obviously come up with search tools and access to the web, back and forth, managing and orchestrating all of that. So earlier part of the year, this was a big thing because it solved a real problem. And then there were OpenAI introduced like chat plugins, function calling, API updates. These things have been constantly being. So I want to get to the RAG part because I know many of you have questions. So what is RAG and why do you use it, and why does it make sense? So essentially, search has always been a huge driver of use cases. The ability for a company to look into its own data set and understand the entities, figure out how to summarize things, how to field a question using a large corpus of documents. That is a really, really important use case for companies because they're sitting on a lot of dark data just not being used. So that's the use case. Hopefully, that the use case is really simple, but the implementation has lots of details. So the main thing is you have to first understand the question, and then you have to find information, which is the best relevant information, and then it will generate the answer. And it uses a special kind of databases called vector databases for embeddings of the text, which gives embeddings capture the essence of the meaning from text and store it so that when you want to compare and match a question with an answer, you can do it through embeddings. And this goes into the details of things like dense search, sparse search, re-ranking. We don't have time to go over all of that, but if you are into searching, then those things are important. And then you can look into any of the courses or some of the blog posts that I have mentioned here. So essentially the idea is that you have your own data set. Let's say your company data set, you have a handbook of HR policy, or you have insurance documents, and you want to pre-train on that. But not all of the documents are in the pre-train. So these are your org and domain-specific data set, which only apply to you. So this stuff is something which ChatGPT kind of model cannot see because it's private data. So now you can create a user interface with a QA system. You can send the search results, and then using RAG and vector databases, the relevant results are sent back And now generated answer is much, much higher quality. So if you want to learn about embeddings, my recommendation is to watch this video from Luis Serrano. He's with Cohere, but he also has the Serrano Academy. Really good explanations. And he kind of walks you through the whole system of what is the vector databases are and what is embedding and how does it kind of helps you with it. Now the vector databases, you can do RAG without it. Okay? So I included these two graphics to kind of give you the basic concepts. See, on the left side is the graphic is explaining why would you need a vector database, what happens without a vector database, and what problem does the vector database solve. So essentially, with a vector database, you can do a one-time indexing of your document and store the essence of those documents in a vector database. And next time you have a query, you can use the whatever tools and technologies you prefer to figure out the best answer from that embedding, and then present that answer back to the user. So the market of these vector databases has become bigger. I think a few months ago, I only knew of a few of these, like Chroma and Milvus and Pinecone. And then what happened is that in addition to these dedicated vector databases, there were other open source databases also started supporting vector search. So all of these Cassandra and Postgres, now they also support it. These are open source as well. If you just want to go with the commercial ones, here are a few. And then there are some commercial databases like Redis and Elasticsearch, single store, that also support this. So if, for example, if you are already using one of these, then you don't have to necessarily get another separate vector database. You can use it. So Elastic, for example, was already used by some companies for storing documents as a NoSQL database. Now it also has the vector search. Okay, so we're getting towards the end. So there were some questions about the ops part and how do you manage the whole thing. So many of the ML ops concepts apply to here as well, but you will see the concept of FM ops, which includes some of the very specific things that foundation models need to keep them up to date and to kind of manage them. But essentially, very much like other ML stack, you need to have the data pipelines. You need to have the specialized databases. You need to manage your APIs and plugins. You have to host the model. So there's a whole stack. So you can kind of show a stack of traditional ML and then compare it with the stack of foundation models, but you can do a stack of the large language models. So, and the question becomes, how much flexibility do you want? For example, you could go with one cloud vendor and use all of their technology all the way from the infrastructure layer to the data services to the UI to manage the models and to manage your teamwork and to add governance. Or you can do a mix and match where you have a hybrid cloud and you can choose to keep some of your data in-house on-prem. Some of the data may be sitting in multiple clouds. And over there now you have, you can combine, let's say, prompt tuning with RAG. And if your answers are going to be coming from external documents, then RAG becomes more important. If you don't have a whole lot of documents that are considered organizational specific or proprietary, and a lot of your answers depend on the model's performance, then prompt tuning and fine tuning becomes more important. But from where I am sitting, I am seeing both. You do prompt tuning, or better, a little bit of fine tuning, but then a lot of the untapped information is sitting in different kinds of databases, and RAG, or Retrieval Augmented Generation, is a very good way to retrieve that information and show the quality of these models. And you can do that in a smaller setting where you can experiment. So the source of this one is A16Z. You can check it out, it has some really good content. So to kind of keep learning, you have to use many of the resources that are out there. I'm going to just leave you with a handful. There are many good on books. There are many good videos. There are good basic introductory stuff with deep learning.ai. So all of these are good sources for you to keep learning. And of course, many of the company websites also give you good information. So quickly answering, looking at the Q&A. So people have asked about embeddings of the tokens. Don't really understand that question. And then opinionated cloud, I think that's just some people's thinking of hyperscalers. Okay. And there's some of the things that I mentioned. And if you want to follow, just here's my contact information. Happy to answer questions. I know this was like a lot of content that I covered in 1 hour. So not enough detail. Maybe we can do a follow-up session sometime, kind of do a deep dive in one of the area with maybe some of the technical details. But any other questions, happy to stay for a few minutes and